Hello and welcome back. We have a math puzzle today about sisters. When Lisa was 6 years old, her sister Lucy was half her age. If Lisa now is 40 years old, how old will be Lucy? So this is the question, this is the math puzzle that I'm bringing for you today to warm up, to think about how to solve it, and at the end of the lesson we can check the solution. Today we will work on Chapter 2, Equations, Inequalities and Problem Solving, on Section 2.6, Absolute Value Equations. The first objective today is to solve absolute value equations. What's the definition of an absolute value equation? Is something like that. You're gonna find absolute value of x equals of a. If you have something like that, you're gonna solve it. First, it's important to say that a is always going to be a non-negative number. That means it can be zero, it can be a positive, cannot be a negative number. Okay, so a is a non-negative number. To solve, we have to adopt two solutions, find two ways of calculating. First is making x equals a, and then making x equals negative a. Negative a. Because if you remember, this symbol here, this brackets here of the absolute value function means that the return, the output of a function like that is the absolute value of the number that's inside here. And basically is the number with no sign. If the number is, let's say, negative 5, it's going to be 5. Is a positive 5, it's going to be 5. Okay? So this is how we solve. Make x equals a or x equals negative a. I'm working on a few examples here. Check this out. We have 6, absolute value of 6 plus 2n equals 4. And we have to adopt two different ways of solving it, right? Two different paths. One, we will make 6 plus 2n equals to 4. And another one, or we will have 6 plus 2n equals to negative 4. In both situations, you will have absolute value of this whole thing equals to 4. And to be able to find a solution, we will apply addition property of equality, multiplication property of equality. Right here, we will subtract both sides by 6. So subtract both sides, and then find 2n equals 4 minus 6, negative 2. On the other side here, we're going to do the same thing. We can add negative 6 on both sides, right? But then here we will have 2n equals, right? Negative 4 minus 6, negative 10. Back to the left hand side, all right? Let's multiply both sides by the same number. Multiply by 1 over 2. And back to the right hand side. Multiply both sides by 1 over 2. And finally, we will have here n equals negative 2 divided by 2, negative 1, or n equals negative 10 divided by 2, negative 5. And here we can see the solution. We will have two solutions for this absolute value equation. Let's work on another example, and now we have absolute value of 2x minus 6 equals 4. And it's kind of the same way, but before we need to have only absolute value on the left hand side of the equation, right? So first, let's simplify, let's apply addition property here to have only the absolute value in one side of the equation. What we will do is to add 6 on both sides of this equation here, and then we can eliminate, we can get rid of negative 6, absolute value of 2x equals 10, right? And now we can go to the next step, the two paths that we will take. One path is having 2x equals to 10, and another path is having 2x equals negative 10. To simplify both sides here, we can apply multiplication property of equality, multiply both sides by 1 over 2, and there we can do the same. And finally we have here x equals 10 divided by 2, 5, or x equals negative 10 divided by 2, negative 5. So we have two answers for this equation, two solutions. Moving to another example. All right, this is an interesting one because we have absolute value of 7x equals to 0. If we think about adopting the two paths that we thought we used before, let me write something here, but don't be too critical. We can say 7x equals positive 0 or 7x equals negative 0. But this is a nonsense, right? We cannot say positive 0 or negative 0. You just have 0. This is just nonsense, right? On this particular situation, we will have only one path, and that means only one solution, which is 7x equals 0. Then x equals 0. This is the only solution for this absolute value equation. Let's try another example. So this one, and here we can adopt the two paths. We can say x over 2 minus 1 equals 11, or x over 2 minus 1 equals negative 11. Now let's solve first on the left hand side here and simplify, apply addition property, add 1 on both sides, and then we have x over 2 equals to 12. And finally we will multiply both sides by 2. And then we have, simplify here, x equals 24. This is one answer. Now let's go to the other side here. Well, we can do the same thing, applying addition property and adding 1, right? But then we will end up with x over 2 equals negative 11 plus 1, negative 10, multiplying both sides here by 2, and the other solution that you will find here on the right hand side is x equals 20. So you can say x equals 24, sorry, negative 20, right? X equals 24 or x equals negative 20. Okay, let me just... Another example. Let's see, we have absolute value of 3z minus 2, and then we have plus 8 equals 1. Again, you need to remember that to apply these two paths that we've used before, negative and positive, we need to have only absolute value function on one side of the equation and everything else on the other side of the equation. So let's move this to the other side by using addition property of equality. Subtract 8 from both sides, okay? And then we will have absolute value of 3z minus 2, right, equals 1 minus 8, negative 7. And this is an interesting situation. Absolute value never returns, never will give you as a result a negative number. See? It's always going to be 0 or positive number. That means this equation here have no solution. There is no way an absolute value will return a negative number. The answer here simply is no solution. And finally, very interesting example. Now we have the absolute value in both sides. Can you see the absolute value? They are in both sides. We will kind of work with the same thing, the same two paths that we've done before. So we will write down here x minus 3 equals positive 5 minus x, or x minus 3 equals to negative 5 minus x. And solve each side, each path. In here we can apply addition property. Let's add on both sides 3. Add 3 on both sides and add x. And we also will add x on both sides. So we add x plus 3 on both sides of the equation. As a result, we get rid of this negative 3 here, and we get rid of this x over there. 2x equals 5 plus 3, 8. Oops. 8, and multiply both sides by the same number. Let's multiply by 1 over 2, and then we can have x equals 8 divided by 2, 4. Let's check now the other sides, and here we will apply addition property and add 3. But first let's get rid of this parenthesis here. Let's get rid of this parenthesis, and we will find the opposite of 5 minus x. Then it's going to be the opposite of 5 minus x is 5, negative 5, right? Negative 5 plus x. And we are adding on both sides 3, and we are subtracting x on both sides. See? And this is going to be very interesting because, well, we get rid of this 3, we get rid of this x here, and we eliminate this other x, and we will have 0 equals negative 5 plus 3, negative 2. And this is crazy, right? This is completely wrong. So in this situation, when we find something like that, we're simply going to say that this have only one solution, and the solution is x equals 4. All right, and that's it. This is the end of section 2.6. Let's we can try to solve our puzzle, math puzzle. What do you think is going to be the right answer here? Well, don't rush and don't give the wrong answer that some students will immediately think about when they read it fast, which is they're gonna think 40 years, half the age, 20 years old. No, this is gonna be wrong. This is not the right answer. Think about, if Lisa is 6 years, then Lucy is gonna be 3 years old, right? So the difference in age is 3 years. That means when Lisa is 40 years, the difference in age will keep the same, will be the same, 3 years. That means the age of Lucy is 37 years old. This is the right answer, and thank you for watching the video. See you on the next section.